So this is the final video for the intermediate level, and we're going to pick up from where we were before, and what we were saying was I'm using the calculate distance function. If I scroll up into where my functions are, I've defined one, and look at this, it looks really long, but actually, as I was saying before, it's really simple. I've just broken down how you calculate the distance between 2 points into lots of simple steps. I do that because it saves error. It helps you eliminate errors. Okay, and when you do this in a function, it's perfectly fine to do this type of thing, break it down in this kind of way, because when you actually come to using it, you don't need to know how it's done. You just use it. Right, so I calculate the distance, pass it into my circle function, and let's draw our circle function. Okay, so bear with me a second. I'm going to draw my function. Now, if I don't fill it so we can see it, what we should expect is some relationship between the line between the 2 points and the circle. So shall we test that out and see if this function works? Right, let's execute that. So I click it here and I click it here. Oh, and it's thrown me an error. So we were just about to look at this error, and what did we notice? What was the error? The error was around, let's run it again so you can see it. Click, click, there it is. This name error, it's saying this thing called global name math is not defined. And you say, not really sure what that means. Name error always suggests that you're using a name that doesn't exist, but actually we are correctly importing it. So there must be something else going on. So I'm going to show you a very, very simple fix for this type of problem. This is a type of problem that arises when you import a library, and sometimes there's a problem with the math function or the library you're trying to import. In lots of environments you can clean the connection to the library and rebuild it. Sometimes you can't in this environment. Now let's ask a very simple question. It's got a problem with it, so I'm going to fix it by asking the function I'm using a power, square root, and I think that's it, just power and square root. So instead of importing everything from math, I'm just going to import power, comma, square root. You'll notice they appear there. So this maths function is just going to import power and square root. When I scroll down, you'll notice that math is still complaining. So let's just delete that. Delete that. So I'm just, now have a look at how the code changes. This is a very powerful trick you do with lots of other programming environments. You actually import the functions you want from a library of functions, and then you don't have to do the math.power. You can just write power, square root, because it knows from this line where it's getting those functions from. Let's save and let's execute. So click somewhere roughly in the center, just did then, and let's click out here. That looks, to me, that looks correct. It looks like there's the line, the 2 points. It looks like it's drawn a circle exactly around from that point to there. So if we go back to our code, it seems to work. But look, if I was a programmer, a professional programmer, what this episode and example shows is that in some environments you're given a libraries of functions like calculate distance. I wouldn't be surprised that even if the math library up here has functions which doesn't do this for you. But by creating our own one here, it helps you understand that there's really nothing more to a function than defining what you pass in, what you do with what you pass in, and what you give back. Once you define a component in that way, treating it as a black box, it doesn't know how it's being used or who's being used. The only rule, it's called the signature of the function, is this top line, the name and these values here. And this return value in other programming languages is often contained in this top line. You'll see that with Java when you come to it, and you'll see it with C# and C++, but in Python it hides it. So that's a function, a black box, a component I've created. I could copy and paste that into a completely different environment and use it to calculate the distance between 2 points in a very different setup. But here's the really interesting thing, is that I'm a client coder, I go to a company and they have all these functions that's already been built for me, that one there, and I simply just use them when I need them. So that's how I use it. I write it on the right hand side, open a bracket, decide where I'm going to give it from my environment. In this case it's P1, P2, it could have just been 2 numbers. And then it will give me back my result and I'll use it in my program. That is the typical way functions work. Functions lead you also into more complex ways of organizing your code. But I want to end this intermediate video on the notion that with functions, you are also organizing code into reusable pieces. And that's a really, really important part of how you do it. With functions, you will also be moving code around a lot. You can spend several days writing a function, taking stuff out of a function, putting it into another one, chopping and changing and working with them. It's very typical to work in as a software engineer and do that type of thing. And so this introductory video gives you a flavor of how the real thing works. What I would suggest you do is code this yourself and look at this function here. This uses Pythagoras. So when you come to looking at other functions which have mathematics in them, hopefully it will give you an insight. Please copy it through and have a go yourself. In the next video, I'm going to give you a more complex setup and I'm going to set the problem out and ask you to use functions to simplify working with this code.